Hello and welcome to Virtual Learning Network. This e-lecture is on Computer Basics and PC Software. Block 1, Unit 2, Introduction to Functioning of a Computer. The topics we are going to cover are Introduction, Components of a digital computer and their role, Number system, Concept of instruction, Elements of CPU and their role. Let's start with introduction. This unit aims to identify the major components of a digital computer. Describe the functions performed by them. Architectural blueprint of digital computers, identifying the major components and their roles. Introduction to decimal and binary number systems and popularly used binary code systems. Understand the concepts of a machine instruction through a simple example. Components of a digital computer and their role. This figure presents a block diagram of a digital computer identifying the key components and their interconnection. It receives data through an input device such as keyboard and displays the result to some output device such as monitor. All data processing in a digital computer is done by a central processing unit, also known as processor. A working memory is used to store data and instructions. The main components of a digital computers are input devices. Example, keyboard, mouse. Input devices are used to read the instructions and data to be processed. Storage device. Storage device which stores virtually everything on the machine. Central processing unit. It processes the data. Output devices. Example, video terminal, printer, etc. It is used to display output. Besides these main components, we find slow secondary storage devices such as floppy disks and hard disks. These can contain data and programs that can be used as input. They also can receive output. Computer as a data processor. Computer takes the raw data as input and performs several operations on these data in order to produce the desired output. So, it acts as a processing unit for those data. In this figure, the data refers to any raw collection of facts, figures and statistics. The input data to a computer may include both numbers and characters. Processing the data thus means manipulation of letters, numbers and symbols in a specific manner. The processing may include calculations, decision making, comparisons, classification, sorting, aligning and formatting, etc. The processing of data results in some meaningful values, often termed as information. We are familiar with decimal number system, which uses 10 distinct symbols from 0 to 9 and has base 10. A number system with base r, here r represent as base, will have r distinct symbols from 0 to r minus 1. Binary number system base 2, octal number system base 8 and hexadecimal number system base 16 are some of the frequently used number systems in computer science. Binary number system has two distinct symbols, 0 and 1. Octal has 7 distinct symbols, 0 to 7, and hexadecimal number system has 16 distinct symbols, namely 0 to 9 and 10 to 15 represent A to F. Binary number system. The binary number system as base 2 and therefore uses only two distinct symbols 0 and 1. Any number in binary is written only by using these two symbols. Binary number can be converted to its decimal equivalent by performing the sum of powers of two of those coefficients whose value is 1. It is equivalent to number 9 in decimal number system. Binary to decimal conversion. The conversion from decimal to binary or any other base R system is done by separating the number into an integer part and a fraction part and then converting each part separately. Here, a binary number 10101 base 2 is to convert into decimal number. Now conversion is done by multiplying base. Here, base is 2 with binary digits start from left 1. Here left 1 position is 5th. So we write 1 multiply 2 power 4. Then left second value is 0. So we write 0 into 2 power 3 and so on. After solving this, we get the decimal number that is 21 and the base value that is 10. So the value is 21 base 10. Then again for next example, we will follow all these rules. Now this slide shows the conversion of decimal to binary. The decimal number 13 can be converted to binary equivalent. By converting the integer, the number is divided by 2 and remainder part is extracted. The quotient obtained is again divided by 2 and this process is repeated until the quotient becomes 0. Every time the remainder obtained is recorded. The set of remainders obtained read from the bottom to top from the binary equivalent of the integer part of the number. Hexa. Hexadecimal to binary. Hexadecimal is a number system of base 16. This number system is specially interesting because in our casually used decimal system, we have only 10 digits to represent numbers. As hexa system has 16 digits, the extra needed 6 digits are represented by the first 6 letters of English alphabet. Hence, hexa digits are 0 to 9 and A to F. This number system is the most commonly used in mathematics and information technologies. To convert the hexa number into binary, just change the digit into the 4 equivalent binary digits. Like this example, D convert into binary by writing 4 binary number. Here D is represented as 4 binary number, that is 1101. Binary to hexadecimal. Binary numbers can only be 1 and 0. Hexadecimal numbers can be 0 to 9, A to F. Since hexadecimal is base 16, you can convert any binary string to hexadecimal, but you need 4 numbers to make the conversion. Here 4-digit number 0010 represent as 2, 1001 represent as 9, 101 that is 10, but in hexadecimal 10 represent as A. 1111 represent as F. Concept of instructions. An instruction refers to an operation that can be performed by the processor directly. An instruction tells the processor what task is to be performed and what micro operations need to be completed to perform the task. Every instruction execution requires execution of a set of arithmetic and logical operations. Every instruction is comprised of two parts, opcode and operand. The opcode specifies the operation to perform and the operands provide the data on which the operation is to be performed. This figure presents the component of a CPU. CPU has three components: control unit, arithmetic and logical unit, and a set of registers. Components of CPU. Registers. Register is used to store the data temporarily. Registers lies cache and main memory. Registers in CPU perform two roles: user visible registers used to store data item, access data useful for machine and assembly language. Control and status register. It is used by control unit to control, coordinate the operations of the processor. Control unit. The control unit of the processor is that unit which controls and coordinates the execution of instructions by the processor. It is responsible for defining and controlling the instruction cycle. Its issue the control signal internals to the processor to move the data between registers. ALU performs specified function. CU timing signals for executing set of micro operations. Arithmetic and logical unit. The arithmetic and logical unit is that part of the CPU that actually performs arithmetic and logical operations on data. The CU, CPU, registers and memory help in bringing the data into the ALU and then taking the results back. ALU has logical implemented to perform operations like addition, multiplication, division, shifting, complement, etc. The operations are performed on represented numbers but integer and floating points number. Now it's time for summary. This unit has introduced you to the components of a digital computer and their role. A digital computer has CPU, memory, input and output as constituent elements. Digital computers use binary language. An instruction cycle involves fetch, decode, execute and write back cycles. The three key components of CPU are CU, ALU and registers. CU controls and coordinates the execution of the instructions. ALU actually performs the operations. CPU registers work as temporary storage for executing instruction. Thank you for this session.